Hi, Washington Liberty Chemistry students. This is your Unit 1 lesson on classifying matter, elements, compounds, and mixtures. And we're going to divide this up into 3 bite-sized video parts. The first part, we're going to discuss pure substances. So as you remember from a previous lesson, a pure substance is matter that has a uniform and definite composition. All samples of substances, sometimes called pure substances, have identical properties. A pure substance can be classified by its physical and chemical properties. And pure substances themselves can actually be classified into 2 categories, elements and compounds. Now, what's an element? An element is the simplest form of matter that has a unique set of properties. It is a pure substance that cannot be broken down chemically into different types of substances. As of 2022, there are 118 known elements. 98 elements are naturally occurring on the Earth, while the other 20 elements have been made synthetically in a lab. Now, we have a way of finding all these elements and categorizing all these elements. The names and symbols of these 118 elements are found on the periodic table. So all of these elements that have these unique properties have a name, but they also have a chemical symbol, which is sort of a shorthand way of being able to refer to them. And they are all found on the periodic table. Some of you may know that the periodic table is arranged by something called atomic number. An atomic number is just the number of protons in their nucleus. We'll be reviewing and talking about that in subsequent units. Now, the symbols for these pure substances, these elements, may be 1 or 2 letters. Now, the first letter is always capitalized. The second letter, if needed, because more than one element may start with that letter, will always be lowercase. So for the example of helium, its chemical symbol is He. That's because H is being used by the element hydrogen. So we have to have a way to distinguish between the two in the symbol. And sulfur, on the other hand, just has the chemical symbol S. But as you may know, there are many elements that start with the letter S, and you're going to see a second letter. And even in the case of something like sodium, you will see letters based on the Greek name. So for example, sodium, which you know from sodium chloride, has the chemical symbol Na from its Greek name, natrium, Na. But S is for sulfur in this case. Now, the smallest piece of an element in nature. Most elements, their smallest piece is an atom. Most elements exist as atoms in nature. And an atom is just a single particle that has the properties of that element. However, there are 7 elements that exist as what we call diatomic molecules. And a molecule is something in which 2 of the same type of atom chemically combined. And that means they are stuck together. We're going to talk much more about chemical bonding in subsequent units, but think of it as just being attached. They're holding hands. They can't separate. Molecules are particles in which one atom is chemically bonded to another. And in the case of 7 of the elements, they exist as diatomic molecules. So here's an example. Helium is a monatomic element. Its simplest piece is a simple atom. And you can see here, we represent this with these drawings of just single circles, not touching. Now, there are 7 elements, nitrogen is one of them, that when they're out in nature, the nitrogen in our air, it doesn't exist as a single atom. It exists as 2 nitrogen atoms, basically holding hands, chemically combined, not separating. And again, this is an element because it has only one symbol, but in nature it exists as a molecule, a diatomic, di meaning 2 atoms that are touching, that are staying together. Now, there are only 7 of the 118 that exist this way in nature, and you need to know them. The 7 diatomic molecular elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, exist as nature as diatomic molecules. So you can find them on that periodic table in a very convenient way. Nitrogen is the element number 7, and it makes a convenient 7 with 6 of them: nitrogen, oxygen, fluorine, chlorine, bromine, and hydrogen, and iodine, and hydrogen is the last one. Now, we write formulas. If it's just an element, then we can just write the symbol. But if it's a molecule, we have to write a formula. And a formula shows how many elements or how many atoms are in a particular molecule. So the formulas for the diatomic molecular elements are H2, N2, O2, F2, Cl2, Br2, I2. And when you have this little 2 down here called a subscript, like a submarine, that indicates that these aren't two separate oxygens, but these are two oxygens that are bonded to each other. The 2 is called a subscript, and it indicates two atoms are chemically bonded to each other. So it looks like this, rather than saying, well, I've got two helium atoms here. That's just two separate helium atoms. N2 means that the two nitrogens are bonded together. Now those are elements. Notice they only have one symbol. What's a compound? A compound is still a pure substance, but its simplest particle is a molecule. A compound is a pure substance that contains two or more different elements chemically combined in a fixed proportion in a molecule. It cannot be broken down, it can be broken down chemically into its elements if you do the right kind of chemical change. Now, an example of a compound is methane. Methane is the gas that we burn in our Bunsen burners and can be burned in your cooking and home heating. Methane is a compound in which there are always 4 times as many hydrogen particles as there are carbon particles. And you can see they are attached to each other. This is a single molecule of the compound methane. It's a compound because there are more than 2 symbols. There's carbon and hydrogen. But it's a molecule because there is more than one atom chemically connected to each other. Methane is a pure substance because it always has the same composition. If you have a sample of methane gas and you reach in, you will always pull out this particle. However, it is not an element because it can be broken down into simpler substances. So chemically, we can break this down. We could break it down into hydrogen and carbon. It's hard to do that, but we can. But with an element, you can't make it any simpler. With just carbon, you're going to only ever be able to have carbon. But with methane, you could chemically break it down into carbon and hydrogen. So let's talk about the difference between a symbol and a chemical formula. Compounds are represented by chemical formulas of 2 or more element symbols and consist of 2 or more elements chemically bonded. Compounds exist as molecules. And remember, the definition of molecule is 2 or more elements chemically bonded. Sometimes we call these molecules formula units. That's when they are the particles are positive and negative ions held together in a fixed ratio by electrostatic attraction. So the word molecule and formula unit are interchangeable depending in terms of what they mean, but we'll talk about when you use them properly when we start talking about ionic and covalent bonding later on. Just recognize that a compound is always going to have 2 or more chemical symbols. Subscripts represent the relative number of each type of atom in a molecule or formula unit. So here's a representation of a molecule, the molecule carbon dioxide. It consists of 1 atom of carbon chemically bonded to 2 atoms of oxygen. This would be 1 carbon dioxide molecule. Notice that if there's only 1, we don't use a subscript, but since there are 2 oxygens, we use the subscript to say that this carbon has the 2 oxygens combined. Now, we actually have 3 molecules of carbon dioxide, and we'll talk about how you represent that. You're going to use something called a coefficient. Let me just show you a formula unit for sodium chloride. So the formula unit for sodium chloride is NaCl. Now you'll notice we don't have kind of distinct particles, but we do have a ratio of sodium to chlorine. There are 2 symbols, and the ratio is 1 to 1. Now let's just talk about coefficients and parentheses. So coefficients are numbers found in the front of chemical symbols or formulas to indicate how many of each type of atom or molecule are present. So we'll talk about that in the next slide, but parentheses often confuse chemistry students. And so I wanted to show you a formula for something called calcium nitrate. And this is the formula for calcium nitrate. Looks pretty complicated, but there's a reason why we put these in parentheses. They indicate something called polyatomic ions, which stay together as a group. So don't let that bother you. We're going to count up the types of elements and the number of each of the atoms of those elements. So we have 3 types of elements in this formula. We have calcium, and I know that's just one element because of the lowercase. We have nitrogen and oxygen. three types of elements. So we know it's a compound. Now, how many of each kind do we have? Well, there's no subscript on the calcium, so we just have one calcium. The 2 that's outside the parentheses is a distributive thing. It indicates we have 2 of these NO3s, which means that we have 2 nitrogens and 2 times 3, 6 oxygens. So in this chemical formula, we have 1 calcium, 2 nitrogen, and 6 oxygen atoms all combined, and 3 different types of elements, but with a fixed proportion of 1 to 2 to 6. Now let's talk about coefficients. So good example here are these 3 chemical formulas. H2O is water. Most of you know that. This is the formula for water, right here, H2O. It indicates 1 oxygen and 2 hydrogen. Now this is a molecule of water. And we know it's a molecule because there is more than one atom. Molecule is just a plural. We know it's a compound because there's more than one type. There's both hydrogen and oxygen. Now notice if I put a coefficient in front, the coefficient goes in front here, it means that I have 2 separate molecules of water. Okay? It's a little different than notice they're not touching, they're not bonded. It's like having 2 separate apples. Now we can still see that this is a compound because they're 2 different symbols, hydrogen and oxygen. If we want to count up how many atoms are in this particular formula, we can see that we have 2 distinct waters, which means that we have 2 oxygens and 4 hydrogens. Now look at the difference. If we had put the 2 down here, that would indicate a different molecule, one that has the proportion of 2 hydrogens to 2 oxygens. This is a molecule of hydrogen peroxide. Many of you may know that as a disinfectant you use on your on cuts and injuries. Now let's talk a little bit and integrate some of what we learned from the last lesson about chemical changes. So how do we represent chemical changes using these formulas? Well, remember, we have a reactant side, the things that we start with, and we have a product side, the things where the atoms rearrange themselves to form new substances. So here is the burning of methane. We have the chemical formula for methane. It is a compound because there are 2 symbols. It is a molecule because there's more than one atom. Here it is represented down here, 1 carbon, 4 hydrogen. It burns with 2 oxygen molecules. Now oxygen is an element. It is the diatomic element with O2. So you can see we have an O2 right here. It's an element because there's only 1 symbol. This is a molecule because there's more than 1 atom. We have 2 of them. The coefficient means they're 2 distinct. They're not bonded, they're 2 distinct. That's why we have 2 of them here. Now let's look at the product side. They've rearranged themselves so that we have 2 carbon. We have 1 carbon here, just like we had 1 carbon here. And the symbol is CO2. So again, this is a compound because there are 2 symbols here, but it's a molecule because there's more than 1 type of atom. It also produces 2 molecules of water. We can see the 2 distinct molecules indicated by the coefficient, and we can also see that each molecule has 2 hydrogens bonded to an oxygen. It's a compound, again, because there's more than 1 type, and it's a molecule because there's just more than 1 atom. Look at one more example. Here's a chemical formula. This would mean 2 distinct molecules of C8H18. That molecule is known as octane. It's like gasoline. It's the formula for gasoline. The coefficient means there are 2 molecules of it, but each of the subscripts tell you the proportion within the molecule. There are 8 carbon atoms bonded to 18 hydrogen atoms. That's a really big molecule. Now, compounds have different properties than the elements that make them up. So, for example, you're probably very familiar with sodium chloride. It's salty, it's a crystalline right solid. But the 2 elements that make it up have very different properties. Sodium metal is a highly reactive metal that if you have enough of it and throw it into water, it will explode. Chlorine gas is a green, very poisonous gas. Yet when you do the chemical change by doing the synthesis of sodium with chlorine, you get this very different substance, sodium chloride. That ends part 1. Take a break and we'll go on to part 2.